Hi all, welcome. So today we are going to see about the topic on security and privacy in cloud. And I am Lavanya, Assistant Professor of CS Department. So today in this unit 2, we are going to discuss about security design and architecture for cloud. In that subtopic, we are going to see is that virtualization strategies, network segmentation strategies. So let's dive into the topic. But what is meant by virtualization? So virtualization is what is that? The managing the workload by making it more scalable and efficient. Some sharing of applications to multiple customers and companies becomes more accessible and such that these will be used in multiple server aspects. So this is all about virtualization. And also network virtualization, it consists of a variety of hardware, software and combined network component. And it also involves storage virtualization, which enables managing all storage as a single resource. And here the sharing of application to multiple customers and companies becomes more accessible and the virtualization technique in a cloud hosting. So combination of virtualization as well as the cloud computing can be the ideal solution for multiple aspects, and these involves desired results for the organization. It's a beneficial, especially to the networks experiencing a rapid, significant, and unpredictable increase in usage. So, what is the virtualization strategies available is that the first one is that network virtualization, second one storage virtualization, third one server virtualization, next one data virtualization, fifth one desktop virtualization, and last one is the application virtualization. So first one, network virtualization. So what is meant by network virtualization? It has some wings to the success of cloud computing. So in this method, the available resources in a network that are combined by splitting up the available bandwidth into some independent channels. So here in this network virtualization, so these channels are assigned or reassigned to the separate devices in a real time, and segmenting the channel reduces the network complexity and makes it easier to manage the devices. And here in network virtualization, it consists of a variety of hardware, software, and the combining network components. It also involves storage virtualization, which enables managing all storage as a single resource. And network virtualization is beneficial, especially to the networks experiencing a rapid, significant, and unpredictable increase in the usage. So this is all about network virtualization. Second one is that storage virtualization. So here, storage. So storage is nothing but it is used to create an artificial view of the storage, thus keeping the physical infrastructure hidden from the clients and servers. It enables to pool the physical storage from several interconnected storage devices to appear as a single storage entity that is managed by a single console. And this storage virtualization is mostly used in some storage area network. We have seen and like different types of networks like local area network, metropolitan area network, and then so many things, right? So similar to that, in the storage virtualization, there's used a storage area network, and it helps the storage administrator to backup, archive, and recovers data more efficiently and quickly. And it is a critical technology that is used in both virtual and cloud environment. It enables the applications to access the desired storage without any information of where it's housed. And next one is that server virtualization. So in this server virtualization, it is heavily used concept in building IT infrastructure to minimize the cost by increasing the utilization of the existing resources. The technique involves masking of server resources, and also this server virtualization, it replicates the physical servers by completely changing the identity or numbers or OS and processes. And server virtualization, it reduces the chances of continuously managing complex server resources. It also uh, allows like sharing or utilizing some large amount of resources, and also it has the capacity to expand the resource whenever it's needed. Okay, and it is a best solution for some small and medium scale application with a limited budget. So this is all about server virtualization. And next one is that data virtualization. So what is meant by data virtualization? So in this technique, it involves gathering data from different information sources to create a single logical and virtual view of information. And this information is accessed by the front-end users like applications, dashboards, with any information of the data storage location. And this data virtualization technique consists of collecting, transforming, federating, and delivering the processed data to the front-end resources. The main aim of data virtualization technique is to provide a single point of access to the information collected from various data sources. So this is about data virtualization. Next one is that desktop virtualization. So the popularity of desktop virtualization grew long before cloud uses some increased tremendously. So before that itself, the desktop virtualization concept was introduced, and this virtualization helps you to some emulate the workstation load rather than the server virtualization. So all thing is that most probably they used to prefer this desktop virtualization. Thus, it enables the accessing of the desktop remotely. It is similar to the SaaS model of cloud computing, which allows accessing the desktop environment remotely. And this desktop virtualization, it allows a secure, portable access to both the workstation and data center, since the workstation runs in the data center. So that is what is used. And here, it is nothing but a technique for isolating the operating system, a logical operating system instance from the client, which is used to access it. So this is about the desktop virtualization. So next we are going to see is about application virtualization. So in this application virtualization, it is also known as application service virtualization. In cloud computing, application virtualization means abstracting the application layer, separating it from the OS, and it allows the computing resources to be distributed dynamically in a real time. It enables to overcome the existing problems like application incompatibility, the existing hardware, and faults like bugs. So this is about desktop virtualization. And last one, application virtualization. So this is all about application virtualization. And in conclusion, I can say that these kind of virtualization, which is fascinating, in the sounds way a fascinating field, right? It is widely accepted in combination with cloud computing as the best alternative to some local data hosting and virtualization. It has a diverse range of uses and benefits that are expanding day by day. Virtualization, it also has become an indispensable tool. That is nothing but even though there is a technological advancement, we are going for this kind of virtualization. And it will be interesting to see how the strategies contribute to the future development and acceptance of cloud computing. So this is all about the virtualization strategies. And if you take some of the applications of virtualization is that where we are going, where we are using is that mainly like, you know, where we'll be using the cloud is that for benefits like remote access or for cost reduction or for disaster recovery, security, and energy efficiency. Say, for example, if users want to access an application from anywhere or any device, you can go for this virtualization by using some smaller or very few physical servers, which reduces the hardware and maintenance cost. And in case of virtual machine, can be easily restored in case of a disaster. And applications are isolated in separate virtual machines, and fewer physical servers are needed, which reduces the power consumption. An example of application virtualization like Google Workspace, right? That is we used to call as a G Suite in Microsoft 365. So there we used to have some these kind of advantage. Okay, so the main advantage is that easier system migration, remote work support, safer application testing, dynamic load balancing. So this is all about virtualization strategies. So next topic is that inter-network segmentation strategies. So here in this inter-network segmentation strategies, it ensures that different tenants in a multi-tenant cloud environment remain securely isolated. It prevents some unauthorized access, lateral movement of threads, and resource interference while ensuring compliance and security. So what do you mean by that? Is that some like, like different tenants or different segmentation within a cloud environment. So it prevents unauthorized access, lateral movement of threads, and resource interference, such that the compliance and security level will be maintained. Okay, so this is all about the inter-tenant network segmentation strategies. Okay, so what are the key areas in which the network inter-network segmentation strategies is used? Is that uh, like benefits of network segmentation is that enhanced security, data privacy, isolation of fault, and scalability. So enhanced security, like it prevents unauthorized access between the tenants, protecting sensitive data from breaches, and ensures compliance with data privacy regulations by isolating tenant data. If one tenant experiences a network issue, it won't impact on some other tenants. So that is why we are going for this internet and network segmentation. And scalability, like it can able to easily add or remove the tenants without some significantly altering the network architecture. And the main consideration in inter-network segmentation strategies is that complexity, performance impact, configuration management. So here, and most probably in Cisco, they will be using these kind of network segmentation. So like managing a large number of network segments with complex access control can become challenging. Why? So that is why like excessive network segment can introduce some latency due to some additional loops, right? So in order to overcome such things, we have to maintain some proper configuration or maintenance of firewall and some other segmentation devices, which is crucial to ensure security. Okay. So what are the inter-tenant network segmentation strategies is that first one, virtual private cloud and virtual network isolation. Second one, subnet based segmentation. Third one, software defined networks and micro segmentation, that is we used to call SDN. And next one, firewall and security groups for access control. And next one, private link and service endpoints. Next one, VPC peering and transit gateway for tenant connectivity. And last one, zero trust architecture, that is ZTA for tenant isolation. So what is meant by a virtual private cloud and virtual network isolation is that each tenant gets an isolated VPC or VNet. That is like AWS VPC or virtual private cloud. In Azure, if you take, that is VNet. In Google Cloud, that is called as VPC. And we used to have separate subnets, route tables, and security groups for each tenant. And also, it prevents a cross-tenant communication unless explicitly allowed. Second one, in subnet based segmentation, uh, that we'll be using some creating some separate subnets for different tenants within a shared VPC. And also, if you take, we'll be using some routing tables and security groups to unexplicitly to avoid some cross-tenant communication. Okay, so this is all about subnet-based segmentation. Next one is that software-defined networking and micro-segmentation. Here, SDN, it enables dynamic policy-based network segmentation. And here in micro-segmentation, we'll be isolating the workload at the granular level, Example like VMware, NSX, Cisco, AZI, AWS security groups with per instance rules. And next one is that firewall and security groups for access control. So here we'll be using some cloud native firewalls like the AWS security groups or Azure NSG to restrict some tenant to tenant traffic. And we have to define some inbound and outbound rules per tenant, and we used to follow some layered security with the web application firewall for publication facing services. And next one like private link and service endpoints. So here we use some private link, let's say for example like AWS private link or Azure private link or Google private service connect to securely connect the tenants without exposing traffic to the public internet. And next service endpoint is here, which enables private connections to the cloud services. And next one, VPC peering and transit gateway for tenant connectivity. So VPC, that is virtual private cloud peering, which enables private communication between the two virtual private clouds. Suppose say for example, if I'm in India and another person is there in UK, if I want to communicate this by using the virtual private cloud, I can able to access the peer-to-peer communication. And the transit gateway, like I can go for like AWS or virtual WAN Azure, manages multiple tenants VPC efficiently. You can avoid hub and spoke complexity in large multi-tenant networks. Okay, so this is about VPC peering and transit gateway for tenant connectivity. And next one is that zero trust architecture for tenant isolation. So never trust or always verify approach. So we can't able to trust, and but we must verify thoroughly. So there is a concept of zero trust architecture, and uses identity based access control instead of network location based security, and it requires continuous authentication and per session access verification. So this is about a zero trust architecture for tenant isolation. And in zero trust architecture, we use some every request which is access resource as if it comes from an untrusted network. And here it enforces some least privilege access and performs continuous monitoring and validation. Like benefit or advantages if you take, like it reduces the network's attack surface, which prevents the lateral movement of threats, which lowers the risk of a data breach and limits the number of points of entry for sensitive data or infrastructure. And what are the zero trust principles is that we don't trust any network, including your own or or assess the user behavior, service, and device health. So choose the services which have been designed for zero trust. Zero trust use cases like in remote users or bring your own device buyer, and cloud-based assets will be going. And zero trust implementation is that granular microsegmentation, multi-factor authentication, strong authorization for both human and non-human identities, and policy enforcement at the time of access and continuous policy evaluation throughout the session. And here in zero trust architecture, we use some access requests. It may be from user, application, or devices, and we'll be verifying each and every access from that. Like it can be of PBAC or role-based access control. Yes, we have seen like various things in the last video. What are the role-based access control? What are the access control methods followed? And based on that, we can determine the access eligibility and the data assets or application the services. By means of that we can able to transfer the data. So this is all about the inter-network segmentation strategies. I hope all might have uh, learned thoroughly and about this particular topic, and I think we can just come on a quick thing. So what are the things we have seen? Yes, we have seen about discussed about the various internet network segmentation strategies, and also we have discussed about the various virtualization techniques. I hope all might be cleared with this topic. We will be seeing in the next session. Thank you all. Bye.